I'm sorry about that. I only have a 15-minute time limit to record video. So basically, I believe the last video left off before I was able to create this second pi group here. But essentially, it was the same thing as the first one. So what we had is we had our expression here, and we determined what each of these variables would be. So we had essentially delta t to the power of 0. I'm sorry, actually, no, delta t to the power of -1, g to the power of 0, L to the power of 1, and then k to the power of -1, as well as q to the power of 1. And so this gave us our expression here, which delta t would went to the denominator. G, anything to the power of 0 is just 1, so you don't see this you don't see g in our pi group here. Length to the power of 1 is on top, k to the -1 is on the bottom, and then q is on the top. So then we get our second pi group, which is just ql over delta t times k, which is our second dimensionless quantity. And then I went ahead and started on this this third pi group here with our remaining variable, which was just beta. And so I started the same process here that you can see, where I was trying to equate these dimensions to determine what these A, B, C, and D, I didn't even write D here, D quantities are for our third pi group. So kind of going through that same process again. I'll try to go a little quickly. So again, we're going to go through each dimension and determine what variables are made up by those dimensions. So mass, we go through it again. We see the only one that has it is D, which means D is equal to 0. Length, we go through it again. We see that length is to the power of, we have B plus C plus D, and that's it. But we know that D goes to the power of 0. T, 0 is going to be equal to, -2B minus 3D. Again, we know D goes to 0, which leads us to know that B is equal to 0, which we then can solve for C, which C is equal to 0. And then we have our final one, which is temperature, 0, which we have A. Go through, we have minus D, and then we actually have, because of the thermal expansion coefficient, beta, which is just 1 over the temperature dimension, is just -1. Again, D goes to 0, which means that A is equal to 1. So now basically what we have here is delta T, A to the power of A, which A is to the power of 1, G to the power of B, which B is 0, L to the power of C, which C was 0, K to the power of D, which D was 0, and then again we have beta to the power of 1. So then our third and final pi group will look like this, delta T times beta. Okay, so now we have our third and final pi group. So it's a bit of a lengthy process, but again, it's very systematic. It's very methodical. It's the exact same steps, just making sure that you understand all your variables, correctly define those variables and dimensions that make them up, determine all of the fundamental dimensions that aren't repeated, subtract that from all the variables that you have to determine the amount of pi groups that you have, and then start going through that analysis problem where you isolate each dimension and go through, which will help you develop basically your system of equations to determine the values of these exponents that you have for your repeating variables, and then that will help you determine what the exponent is that will make up your dimensionless quantity. So like in pi group 1. Okay, so now that we have that, we have all the pi groups, so we basically successfully completed this problem. But there was one more thing that the problem asked to do, which was basically say that we need to rewrite in dimensionless form if it is known that G and beta appear only as the product G times beta. So in order to do this, we see that, well, pi group 1 has G in it. Pi group 2 does not have G and does not have beta in it. Pi group 3 does have beta in it. So now we essentially need to just take pi group 1 and 3 here to determine our well, just to basically answer the question. So now we'll take these two, we'll multiply them, and then we have pi 1 times pi 3, since we're saying that g and beta only appear together, is going to be equal to, well, again, our pi group 1 was v squared over g over L cubed, v squared over GL cubed is going to be, well, actually, sorry, let me take a pause here. And I'm actually going to rewrite this expression here. I'm going to flip it, or essentially raise pi 1 to the negative 1. And that's okay to do, because even if I, flip this equation over, and I have GL cubed over nu squared, that's still a dimensionless quantity. It still represents the same dimensionless group. So it's okay to go ahead and do that. So now let's go back this up, and we're going to say, let's raise this to the power of negative 1, so GL cubed nu squared times, well, we have delta t times beta, which is just going to give us GL cubed delta t beta all times nu squared. And so what this basically says is that so we know that, going back up to here, we have q as a function of these variables, q as a function of all these variables. And the only pi group that contains q in it is pi group 2. So what we're saying is that pi group 2 is a function, or essentially was a function, of pi 1 and pi group 3, which we have now decided to represent as a function of the product of 1 times 3. So basically what I'm saying is that pi group 2, which is q times L over delta t times q, is equal to GL cubed delta t beta all over nu squared. One thing to, and this is a function of this. So here's our two dimensionless groups. This right here, in case some of you have noticed, that this is the Grashof number, which is, again, just a dimensionless quantity similar to like Reynolds number, that is kind of an important quantity in fluid mechanics and things like that. So basically that's the answer to this problem.